Hey, some fantastically good news. Some of you really excelled on Monday's assignment. It was so nice getting some real quick feedback from some of you. They came in early, they came in with some nice work shown, uh, correct answers, but didn't have everyone reply. Some of us are obviously more adept to working with quick schools and finding assignments online. Some of us are obviously still getting used to this routine. And so today we're doing just one lesson again, right? I know a lot of times we do two different PowerPoints and have two different worksheets and sometimes even throw in an IXL assignment, but just until I am confident that everyone is being successful and that everyone's getting work turned in on a timely basis, we're going to take a look at just one lesson today. I know some of you are capable of working a little more quickly, but we'll pick up speed when I feel that everyone is being successful submitting their work in a timely fashion. Those of you that have completed Monday's work, congratulations. Thank you. For those of you that are maybe still getting used to the system, let's try to get you caught up, and maybe on Friday we can go kind of full tilt and do our usual amount of work on one day. So this is going to be properties of kites. All right, so again, we're in the land of quadrilaterals, so they got to be four-sided shapes. And kites are another one of these weird family relatives. And I guess if the trapezoid is the weird uncle, maybe the kite is the weird aunt. They are not parallelograms, right? Now we do have some sides that are congruent, but notice they're not opposite sides, right? And so we don't have anything as far as being parallel, right? These sides are not parallel to each other, but we do have two sides that are congruent, but they're consecutive sides, right? So you got two different pairs of sides that are congruent to each other, but they're not the opposite sides. Now, the diagonals of a kite are perpendicular. I'm wondering if any of you caught my mistake in the previous PowerPoint narration. All the slides were correct, but when I was kind of just talking off the cuff here, I inadvertently said that the diagonals of a parallelogram have to be perpendicular. That is not true, right? The diagonals of the rhombus had to be perpendicular to each other, and therefore the diagonals of a square are perpendicular to each other. So the kite is the other object where the diagonals must be perpendicular. So that kind of help us out, because anytime we got a right angle, you're thinking, hey, I can use the Pythagorean theorem. A squared plus b squared equals c squared. And then the other neat thing about a kite is that two of the angles are congruent. All right, and if you take a look at the diagram, you can see which angles they are. Right, so they're not the angles where the congruent sides meet at a vertex. Instead, it's the angles where you have the two different measurements meet. Right, if you look at angle B, that is a vertex where you have two congruent segments meeting. So B is not one of the angles we talk about. Same thing with angle D. Angle D is another angle where two congruent segments meet at a vertex, and so that is not the angle, right? The angles that are congruent in this picture would be angle A and angle C. Okay, so we've got a nice little kite here, right? It is a quadrilateral because it's got 4 sides. It's a kite because we have 2 pairs of congruent sides, but they're not the opposite sides from each other. So we need to find the measure of angle G. Measure of angle G. Well, I know if it's a quadrilateral, the interior angles must add up to 360 degrees. Does that enough help to get us started? Ooh, I also know the measure of angle E has to equal the measure of angle G. All right, so I know that the 4 angles must add up to 360 degrees. And notice that I was able to substitute angle G for angle E. And of course, I can now substitute the value of 40 degrees for the measure of angle F. I can substitute 100 degrees for the measure of angle H. Combining like terms, I have 2 of those measure of angle G's. The 40 degrees plus the 100 degrees is 140 degrees. I still have that 360 degrees on the right-hand side. What would be a good thing to do here? I'd probably subtract 140 degrees from each side. Finally, I don't want 2 times the measure of angle G. I just want the measure of angle G. Let's divide by 2. Now notice, since we weren't like trying to solve for a variable x, that degree symbol is still hanging around. Right? Quite often in these pictures we'll declare, oh, x equals 2 or x equals 7 or something like that. Here we're actually finding the measure of the angle, so that degree symbol just stuck around the whole time. Right? I think you'll find that this is pretty straightforward. There is a worksheet today. And you can try and get that completed. Again, if you're thinking, hey, we're just not doing enough math, we'll see if we kind of ramp up expectations on Friday. But right now, I just really want to make sure that everyone is able to access what they need to access online, and that you're able to submit work to me. And once I'm quite confident that all of us are able to do that, then we'll resume working at normal speed. But until then, just do the best you can on this one assignment. And if it doesn't take you very long, well, enjoy some spare time for the rest of your day. And let's get all through this. It'll be fun. It'll be exciting. It'll be fun and exciting.